Hi everyone, this is Victor, and I wanted to make this video going through our manipulating data lab assignment, just to kind of show you a really thorough introduction to like how I would organize my workflow in solving the lab, and so you can see some of the more smaller details on how R works and kind of the general workflow of how you should organize your files and data for the labs in this class. And so the lab I'll be going through today is the manipulating data homework that we went through a little bit in class last week. And I just really want to go really thorough, go through the setup, data frames, mutate, filter, and select. I'll leave the challenge for yourself to work on. And it's this assignment, right, is targeting just kind of learning the basic manipulations that we do to data frames, or like those kind of spreadsheet tidy data type objects, and working with data, right? And I just wanted to go show really thorough how this works. And so I've already downloaded the folder here, this lab folder, which I created on my desktop, and I've already uploaded the data from the Google Drive, from my class drive, into this folder, where it's the education small data, which we'll be using for this lab. And so let's get started. And so first things first, right, the lab asks us to kind of read in the data in R, and so then we need to open up R. So I have RStudio open here. First thing you want to see is that here on the top right, it says project none, no project. And so I want to create a project that has where I'm going to be working in R. I'm like setting up my workspace. And so in that, we can just click this top right button, click new project. From here, I already made a folder or directory, that's another name for folder, on my desktop. So I'm going to be using an existing directory, and I'm going to browse my computer and see it's on my desktop, and I have this lab folder here. I'm going to open that folder, create a project. And I'll show you why we do this very shortly. So here on the bottom right, we can see that it has opened up the lab folder, and I can see the CSV file, education small data.csv, and there's this new rproj file. This rproj file just kind of tells RStudio that this folder or directory is now like a self-contained project. And I'll show you, that'll become apparent why we do this when we read in the data. And so we want to solve this the lab exercises in an R script. So if we look at the R manipulating data frame, it says create an R script to record all answers and code to answer the questions. So let me show you how to do that. So here on the top left, we have this kind of blank square with a plus sign. This says new file, and we can open up R script. R script is the kind of where we want to work. You can see here that it's an untitled one file, so I want to save that. So I just did the hotkey Control S, right? So you can also just click the floppy disk, save current document, and then I'm going to name this dplyr lab. I think I misspelled dplyr there, but that's okay. And first things first, we want to set up. So we want to read in our data set. We want to load our dplyr package and then read in the data. So I'm going to call this section setup. The reason, so reminder, this pound symbol is a comment, and so it allows us to write normal text without it being interpreted as code, right? So if I go into the console here on the bottom, right? So quick reminder, this is where I can type in code and just kind of have it run automatically. And if I type in normal text, I press enter, it's going to be an error. But if I do a comment, normal text, nothing happens because it's a comment. So the reason I do this syntax here, this pound, space, some text, and then these dashes, is that then that shows up in the outline, document outline, which can be really useful to organize an R script file. So first things first, we need to read in the package. So if you haven't installed dplyr, there's two ways to do it. You can go into the Tools tab here on the top and click Install Packages, and then type in the dplyr package here, and click Install. So that's one way you can do it. Another way is in the console here below. You want to type in Install Packages and then quotation marks dplyr, like that, and you'll see it'll install the package. I already have it installed, so it didn't really have to do anything special for it to install. You don't want to install package inside your code, because your code will be run every single time you run your script. And so having in your script file this line of code will unnecessarily make it install packages over and over and over again, right? And so it's not good practice, right? Remember that our script is like instructions for how we want our code to run. So we want it to be generally well organized, easy to read. Not read in package, load package. So we can do the library function is a library, and then RStudio by default gives us a lot of different options for all the different packages we have installed on my computer. And so dplyr is the package of interest here. So I just Control Enter. So you can see here, when I press Control Enter, it just takes this line of code and automatically puts it into the console and runs it. And you can see here that I got some text. Particularly, I got some warning messages that like my R version is not up to date, which is fine. That's not dangerous. And then these texts refer to that there's some overlap with function names. So dplyr has some functions in it that are duplicated functions with other packages in R. So particularly this filter package. If I do question mark filter, that's how I check up the documentation of packages. I run that in the console. You can see here I get two options: keep rows that match condition and linear filtering on a time series. This is in the dplyr package, this filter, whereas the other one is in the stats package, this filter. And so these functions have the same name, and so sometimes that can lead to issues where you're thinking you're using one filter, but then you're not. That won't be a problem in this exercise because we're only working with one package. But if it was going to be an issue for your work, if you want to specify which function to use from which package, this is the notation for that, the syntax, where you do the package name, :, the function name. And so that's how you can use a specific function from a specific package. Great, so next things first is we need to read in our data. So our file here, if I go to the Files tab on the right, I can see I have education small data.csv. So the way to read in CSV files, one function is the read.csv function. It's data input, and then you can see here that multiple functions came up because you can use different functions for the same thing, and they just kind of have different defaults. Here, the read.csv function is what we're interested in, and we can see the first argument is file. And so what is that file? A file is usually a path. So this is a lot of text here for what this file represents because it can be real complicated. But really, all we need to know is that it's a file path on your computer. So when I do read.csv, I want to read in education, and if I press tab, it should autocomplete because it knows where this file is. And then if I just run this code, you can see that it output to the console just the data itself. And so I want to save this, so I need to use the assignment operator. So assignment is this less than symbol and this dash. And so then we can say that this is the data, dat. You can see here, now on the top right in the environment tab, you can see that my data here is found. So the short aside for why this code works is that it's because we have a project that this text here is the location of our file. So if I go back to my desktop and I open this folder and I right click and I click on the properties, I can see that this is the location of this file. It's in somewhere. It's the absolute location of the file on my computer. So if I copy as path, and I can take a look at what that looks like in R, you can see here, so this is the full absolute location of that file. And by specifying our project to be the lab folder, it basically makes the starting point this lab folder, which then makes it easier to find the files you're interested in. If your files were all random places all over your computer, you are going to need to use this absolute location. And if you are doing this, one common mistake that happens is that you just take this file path and you just put it straight into read.csv. And so if I control enter this line of code, you can see I get an error. So here on the bottom, I get an error, which is that there's like \u used without hex digits and character string. That is a very obtuse error. If you don't know what that means, it's like it doesn't tell you anything informative. Basically, backslashes in R are a special character. They're an escape character, and so it does not like it in file paths. So you either need to replace the backslashes are fold this way, / this way, with forward slashes. So here I'm replacing all the forward slashes. And then now that line of code works. So you can see here I ran it without any error. The alternative strategy is to do two backslashes. Two backslashes will also fix that problem. And that's because the backslash is a special escape character that I won't go into what that means. So those are the two things. When you're using absolute paths, then that's like on Windows, that's like a big issue, is because these backslashes are special characters. And so you need to either use two backslashes or /. So that's why we like projects. That's why we like to look at use an R project, is so that we don't have to use this absolute paths. So I'm just I'll keep the code here for whatever sake. I'll comment it out though. And so next things first, if we go back to the lab, so we loaded in the package, then we read in our data. Now we want to ask ourselves, how many students are in the data set? So before we dive into this question, let's read the description of this data set. So we can see here, this data set, the CSV file, contains observations of students' test scores on math and reading subjects for fall and spring. Reading tests were scored from 0 to 20, and math scores were scored from 0 to 40. So this is important context because it tells us, kind of gives us hints on how we should be interpreting this data set. So one thing we can do is we want to look at the head of the data. So what the head does is it just kind of tells us the first 6 observations in the data set. What does it look like? And you can see here I have some kind of pub ID, maybe some public ID variable. Then we have this name column or variable where we have Alice, Bob, Charlie, David, etc. Then we have these columns, which are I would assume fall reading, spring reading, fall math, spring math. Now, I did not provide you with a code book that tells you what exactly each column represents. That's very common practice in real data situations. So I'm just using my intuition to say that fall reading, FA read, is the fall reading score. In reality, you would want to consult with a code book that tells you what the variables represent. And so it seems that each row in this data set is associated with a particular student. Now, if we wanted to count how many students there are, the nRow function will provide us with that information. So I just typed in nRow data. I got 200 is the number, and that's the number of rows. Which is, so there are 200 students in the data set. Now, I don't need to run this line of code to know this information. On the top right here in the environment tab, we can see that it tells me there's 200 observations. Running this code is just kind of me teaching you to be like, hey, this is a function you would use to check how many number of rows there are. So the next thing we have to do is how many columns are in the data set. So columns is interesting. To check the columns of a data frame, it's the length function. So you can see that there's 6 columns in this data set, right? So if you look at our head, here we have 1, 2, 3, 4, 5, 6. And here on the right, in the environment section, we have 6 variables. So length is the function you would use to check how many columns there are. Okay. Now, the next activity is for check view and summary on the data set, and if anything looks weird in the data. So we're just trying to investigate what, if anything, looks weird. And so here, well, let me add a comment here that says 6 columns. So if I do summary on the data like that, what happens is that for every column, whether if it's considered a character or a numeric, it'll summarize kind of some key descriptives. So you can see here for pub ID, it's counting it as a number. So it's like, here's the minimum ID, here's the maximum ID, and then these are different statistics. The mean here represents the average, median, first quantile, third quartile, so on. And so name here is text, it's a character. And then we have our descriptives of fall reading, spring reading, fall math, spring math. And now if we click view, capital V view function on the data, we can just kind of browse the data itself. Now this is very helpful way of looking at a data set, because we can also use this search tab to search different things. If we wanted to look for Alice in this data set, we could. And so this is a very quick way to kind of get investigate the data. Now, we are asked to find anything weird in this data set. So what do we know about this data set? Let's go back to the lab. We see that reading tests were scored from 0 to 20, and math scores were scored from 0 to 40. So these are minimum and maximums that these columns should be. And so you can see here that when I'm viewing this data set, I see these 999s, right? Those are outside the range of what these scores should be, and so that's weird. Here on the bottom, we can see summary. We can also see that here. Maximum 999, minimum 0. Maximum 999, max 999, right? So these codes are the weird values that I wanted you to notice. And so next thing we want to do is to replace these 999s with missing codes. So NA, with NA values. So that's here in the lab. And this is where we're going to be using mutate. And so we have replaced the weird values in the test score columns with NA, if else. The function if else may help with this. So again, this is where having a code book is really helpful, because these codes 999 we're assuming mean missing. But in reality, if this was your data, you'd want to see what that represents. So here I can say the comments mutate in this notation, and I can see then I get a mutate section. So let's start using the mutate function. So mutate How it works is it takes data in the first argument. Let me look at the help page for this. So it creates new columns that are functions of existing variables. And how it works is it takes the first argument is like your data frame, and then this dot 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 is basically all the columns you want to create. And now you can consult with the slides or the examples on the bottom of this help documentation to kind of see how it works. You can see that they're using pipe to kind of showcase how these function works. So our job is to replace the reading scores. So these are the columns: FA read, SP read, math read, spring math. Replace these 999s with the value NA. NA, remember, is a special value that indicates missingness, not applicable. It has special properties that if you do math on it, it kind of overtakes anything combined with an NA becomes NA, which can sometimes get you into trouble when you don't remember that that property exists. So we want to redo these, rename these columns, right? So I'm going to use the pipes. So a reminder, right? This is the base pipe. The alternative pipe is this, where it's the %, less than %. Both pipes for this exercise do the same exact thing. There's not any differences. If you're interested, you can kind of Google what are the differences between these pipes and what are the pros and cons of which is which. I prefer the base pipe. So we want to use the mutate, and then we want to create a new variable, new column. So if I do FA read, I'm just going to for now name it as FA read NA. I'm going to call it that. And I'm going to say equal to, and it's going to be FA read. And then I want to use the if-else function. If-else function, FA read, if it's equal to 999, make it NA, otherwise make it itself. So what is that function going to do? If I run that, I just ran that code without saving it. It just output it to the console. You can see here at fall reading NA, here's the fall reading column. For David here, he had a 999, and now it's NA. But for Alice, Bob, and Charlie, they had a 7, 6, and 5. They were just their existing value. Now that's how this function works. If else, what it does is it checks a logic. So this was here I said, does fall reading score equal 999, comma, if it does, yes. Here on the right, yes. If it's true, I want NA. Otherwise, I want it to be just the original score, fall reading. So if it's false, give it this score. And so that's how you would replace it. Now I will just overwrite the data. So here I can just say fall reading equal to this if else fall reading equal 999. And if I press enter, you can see here that there is no longer a new column. It is now just overwritten. So fall reading 765, and you can see David's score is now NA. And I like to overwrite these columns because we're just kind of cleaning the data set. We're not making any like crazy summarizing weird transformations. So I generally overwrite the column if it's a simple transformation like this. Now we want to do that for all the columns: fall reading, spring math, fall math. And so I'll write it again. First fall math, if else, fall math, if it's equal to 999, give it NA, and then we want to give it fall math. And then let's do again, spring math equal to if else, SP math equal to 999. If it's NA, SP math, and then make sure all your parentheses are closed, and then the last one is spread. Spread equals if else. Spread equals 999. NA spread. So if I don't close this parenthesis, let me show you what happens, because that's a very common mistake. If I just run this code, you can see here I get error, unexpected comma in blah blah blah, spread this, right? Again, this error is not very informative. It doesn't tell me exactly what's wrong. RStudio is kind of telling me here, unmatched opening bracket. And so that kind of tells me, oh, there's something, I need to close this. One thing that can happen is that like you will run this code and then add something in the middle. You'll make some change here, and then you forget to add a column or add a comma, and then you'll get errors like that. So you want to make sure your syntax is correct, that you have commas for every column that you're adding, and that everything is, the parentheses are matching. So if I run this, oh shoot, I have an error here. I did something wrong. Oh, here it is. So here you can see I closed the if-else function, parenthesis, and then I added, I didn't include these arguments inside the function. So that's another common mistake that happens, and it just happened to me just now. So I can delete this, and so now the if-else parentheses are including the content, and then now I need to close the mutate parentheses. As you can see here, now I have NA for each of my columns. So I'm going to save this as itself, the dat, assigning it's that, and that's just going to override the data. Now, if you were doing something different, or you wanted to keep the raw data, sometimes I call it clean dat. Clean dat, so that if I notice an error earlier, I have the original data set to compare to. So if I do summary on this clean dat, because we did these changes in order to make the values less weird, so let's make sure that that worked. So you can see here that now I've done summary on the data. I can see here that NAs, it counts how many NAs there are in the numeric variables. And I can see that the minimum is 0. For the maximum was 19 for fall reading. Spring math 1 and 19. Fall math 4 and 37. Spring math 5 and 38. So we know that these ranges of math should be between 0 and 40. And for reading, it should be between 0 and 20. So we fixed the problem. We noticed that it was something weird in the data, and we fixed it. And so this skill of investigating the data and kind of checking yourself to make sure when you make a change that it actually solves the problem is very valuable. And I regularly do that when I'm cleaning data. So next step is to calculate the change per student from spring and fall for reading and math scores. So here I'm going to take my clean dat, and I'm going to need to make new columns. Mutate, and I'm going to say read change. So the change score from spring to fall, right? So I'm going to say spring read minus FA read. So it's going to take the spring reading score, subtract the fall reading score. And if I run that, you can see here that now I have read change now indicates the 2. Sees the value 2. For Alice, their fall reading was 7, and then the spring reading was 9. So they had an increase in 2. You can see for David, he was missing his fall reading score, and his spring reading score was 10. And so then here it's an NA, because I took a 10 and I subtracted an NA from it. So then the change was NA. And that's really useful, because before, if this was 999, this reading change would be, negative 989, right? Because it'd be 999, or it'd be 10 minus 999, right? And so then this NA value would be some nonsensical value. It would be something in the 900s. So this is where it's useful that like NA kind of carries over, because then this is NA too. This should be NA. There's other times where it acts is a bit more annoying, but in this case it's very useful. And then we need to do the same thing with math. Math change equals sp math minus sp fall math. Now I want to showcase just one thing. If there's a typo in the columns, so for example, if I say call this F, capital F, a math, if I try to run this, I'll get an error. And so this is an error in the mutate function. And then it tells me object, capital F, a math, not found. So this error is a little bit more useful. It tells me that, oh, I might have had a typo in FA math and should be lowercase. Great. So this looks good, and I want to save this as clean.dat. So I'm just adding the columns to clean.dat. So that's the simple mutate. So we had it, so we were just kind of overriding columns, just transforming existing columns and overriding them. Then we had adding new columns. Those are the kind of two simple use cases of mutate. Now, next things first is filtering. So filtering, we want to filter, make a filter section. So again, if I show the outline, we have mutate, filter, setup. So in filter, the first thing our lab asks us to do is that students who have a spring math or reading scores less than 5 get invited to summer school. Create a data frame of these students. And then it gives us a hint that the OR operator, the vertical bar, will help with this. So we know students that are have less than 5 in the spring reading scores or math scores, is it? Spring math or spring reading. Need less than 5, so that by the end of the spring they had too low of a score and they need supplemental instruction. So here, right, we could, without programming, manually look through the data and just kind of pick out students and just write down which students have less than 5, right? But that can be very time consuming because we have 200 students. So this is why code is useful. So let's take our clean.dat and we're going to do filter. So filter, I'm going to say sp read needs to be less, if it's less than 5, right? Is it less than or equal to? Let's see here. Less than 5. So it's just less than 5. So if they are equal to 5, they don't need to be invited to summer school. Or fall math less than 5. So here I'm using the OR operator to combine, like if a student's less than 5 spring math or less than 5 in the fall math, oh sorry, not fall math, it should be spring math. This should be those students who are invited to summer school. So if I press enter, I can see the output here. It's a bit hard for me to just check to see if this is working. So let's go through, let's assign this as summer school students. You can see here that this summer school students had 16 observations and had 8 variables. If we do summary on the summer school data, we should see here that the spring reading, the maximum shouldn't be larger than 4, right? So in spring math, we see there's an issue here that, because of the OR statement. So it's either or. So spring math could be higher for each individual students, but if it's the both conditions. So it's either I guess this means that no student had less than 5 SP math here. Is that true? Let's check that. So whenever this is just seeing if something looks weird. SP math less than 5. Take the sum of this. Oh shoot, it's na dot am true. So there actually were 0 students that had less than 5 scores spring math. So we don't actually need this condition. This condition doesn't add much, but it's important for learning to know how to do that. You can see here that this NA, well, let me explain what I just did here. So I noticed that the minimum spring math score was 7, which is greater than 5. So that means in all our data, no student had less than 5 spring math. And I wanted to check that to see if that was true. And so this code here produces a logic of like true and false. And then for those that are missing, it's NA. And you can see here that it's all false. And so then I basically then counted the sum of this vector because true plus true is 2, but false and true can be considered as 1s and 0s, right? So true. So if there were any trues, if there were any students that were less than 5, that would be 2. Like that would be counted as saying this is the number of students. And then here, because it produced NA, because there's NAs in here, it didn't give me a true count. So I added this extra argument to say NA.rm equal true, which means missing. If it's NA, remove them. Then it did give me a count to 0. So that's interesting. So it's interesting to know that there are no students that have less than spring math, less than 5. Very cool. Very cool. So that's an aside. Now, students who improve their math scores by 5 points or more from fall to spring get awarded a medal. How many students get medals? So we calculated the change score. So what is it? Is it for math? It says math score. So we need to find the students that have they improve their math score 5 or more, right? 5 or more. Okay. So if I do, oh shoot, I forgot. Let me finish this. To finish this question, NRow summer school will tell us how many students will be invited to summer school, which is 16. Now we want to take our clean.dat pipe, and we want to filter. Now we want to say math change. So I named this column math change, and we want to say 5 or more. So if it's greater than or equal to 5, how many students have that? You can see here, this is the data set. So let's call this medals. Now if we do summary on medals, you can see here that math change, the minimum value is 5, which makes sense. Now, how many students get medals? Medals, 38. So 38 students improve their math score so high that they'll get a medal for just kind of turning around in the middle of the year. So that's simple things we use with filter. Just an example of the OR, and then greater than or equal to. Now, next is the select function. And so here, a researcher would like to look at our students' math scores data, but we need to remove the names from the data set for anonymity. Prepare a data frame that removes the name column and removes the reading scores. Okay. So we want to have a select, and then we want to have our clean data, and we're going to use the select function. Select function, if we look at the documentation of select, and when it comes to learning how a function is used, literally all your resources you should utilize. So go online, watch tutorials, read documentation, see examples, just play around with it, create a test example and see if the function behaves in the way you think it does. Because sometimes reading the documentation alone is like maybe too detailed, and like it makes it harder to understand what the function's doing, especially early on. And so here, select and optionally rename variables in a data frame using a concise mini language. And you can see it has a lot of details in select because there's a lot of customization that you can do when you're selecting columns. Okay, so for our purposes, we're just interested in removing the names column and removing the reading score columns. Now, when we're selecting columns, it's important to recognize what are the exact names. Clean that. So the names function gives you a vector of all the names. And so we can see here that name is lowercase name, and we need to remove the reading scores. So select how you remove reading scores. There's multiple ways. I like to use the minus sign. Minus sign name, comma, minus sign FA read, comma, minus sign SP read. And you can see here now this data set it has the reading change column, so let's remove that. Minus sign read change. So you can see here that pub ID, fall math, spring math, math change are the only columns in this data set, and we remove the name and then the reading information. Okay, so let's call this math dat. So that's all we were asked to do, is just to remove some columns. That's what select does. Now our last task is saving the data. So save a CSV file that contains the data from the previous questions to send to the researcher. From the previous question. So this is our secret, this is our math data. Now to write a file, save.csv. It's going to be the write.csv function. Now how this function works is that we need to give it our data, math that, and then we want to make sure I remember file. File is the argument where we tell it what to call it. So file equals to math data.csv. If I save this and I open here my files tab on the right, you can see here math data.csv has been written. So let's read, just to make sure that we saved it correctly. Let's read it back in. Math.save. We're going to do read.csv, math data.csv. So that was me using tab to autocomplete this text. So if I take a look at this, you can see here that here are the math columns, but then there's this additional column, X. And that is because by default, the write.csv saves the row numbers in the CSV, which is annoying. And so the way to change that is if I look at the documentation of write.csv, let's see here, row names here. This argument controls whether or not the row number or if they're named something, the row names. So we can add that to make it false. Comma, row names equals false. So if I rewrite it and then reread it in, I look at it, you can see that that X column, which originally saved the row names, which were just the row number, is gone. So now here's the data set. Great. And so that's the kind of a really thorough understanding of how to go through the lab. Like I said, go through the challenge on your own, get that practice, and it's really takes a lot of memory and practice to kind of avoid those kind of typical mistakes of like forgetting a parenthesis, or make sure you remember to put a column somewhere, and then also just understanding what these functions do. It can take some time to really build familiarity. And we'll have the further workshops where we'll continue to use some of these functions and packages and continue to grow our knowledge. And so that's all I have for lab today. So thank you so much.